Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our TensorFlow JS course. In this lecture, we are going to answer the question, what is machine learning? Let's first discuss what is a machine learning algorithm. This type of algorithm is one that can learn from data and can improve. Machine learning seeks to answer two questions. First, how can we build computer systems that automatically improve with experience? And what are the laws that govern all learning processes? Let's look at some concrete examples of machine learning. First off, one example is data mining historical medical records to learn which treatment you will best respond to. We're taking data and we are training an algorithm to learn which treatment you could potentially respond best to, and the algorithm will make that prediction by looking at trends in historical data. Another example is building search engines that can automatically customize to your interest. So as you make more searches, the search engine will learn what you are interested in, and therefore it can customize based on your personal data. Another example is designing autonomous robots that can learn to move based on their own experience. Similar is an autonomous car that can learn to drive by its previous driving experience, and it improves with its experience. When should you use machine learning to solve problems? Well, there are two main cases. Number one, when the software or algorithm that you need to build is too complex for you to manually design. For example, if you're trying to perform image classification, classifying images into what is inside of them, like dogs, cats, birds, well, that algorithm can be too complex for you to design because you have to find a way to represent each image with code. Another case is when the software should change after it's been released. For example, if you want to create speech recognition software. For speech recognition, typically that type of software will adapt to the user's own voice. It will adapt to their dialect, their accent, their tone, and therefore that kind of software is not static. It will change after it's been deployed. And that's where machine learning should be used, because the software needs to change on its own without your direct manipulation. Let's talk about the three branches of machine learning. Machine learning is an umbrella that contains three branches. First, supervised learning. Next, unsupervised learning. And third, reinforcement learning. Supervised learning is where you feed your machine learning model labeled data. For example, if you're trying to classify images, you will tell the model, this image is a dog, this image is a cat. That's directly opposite to unsupervised learning, where you force the model to find its own patterns. You don't tell the model, this image is a dog, this image is a cat. Instead, the model will have to find the commonalities in the images on its own. It'll have to recognize, oh, these two images look similar, therefore they should both be in the same class. Then the third branch of machine learning is reinforcement learning, where your machine learning algorithm is going to be improved with reinforcements. Let's talk about the machine learning workflow. This is the workflow that you will take whenever you build a machine learning project. First, you will gather your data. You'll find the data sets, such as the images or the historical records. Then you will pre-process the data. Often data is very messy and noisy. It needs to be cleaned. It needs to be formatted to be able to work with the machine learning model. Then you will train the data by feeding it into a machine learning model. You have to train the model itself because the model starts off with low accuracy, but then with a model or parameter tuning loop, the model tunes itself, so it improves itself by adjusting its equation. Inside of this improvement loop is the training of the model and also the testing of the model, because the model performs one training and then it tests itself to see how accurate of results it gets, and then it will retrain again and retest and retrain and retest until it has high accuracy. And that is known as the model or parameter tuning loop. The model is improved. And then at the end you can deploy the model and you can use it to make predictions. For example, you can use it to classify new images. You can use it to predict the medical treatment for a new patient. You can use it to drive in an unknown terrain, depending on what machine learning model you're building. That is the machine learning workflow. And that does it for our overview on machine learning theory. Now that you know what machine learning is, in the next lecture we're going to talk about Tensorflow Js specifically. Tensorflow Js is a library for machine learning, and we'll dive deep into it in the next lecture. Hello everyone, and welcome back to our Tensorflow Js course. In this lecture, we're doing an overview of what you will learn in this course. This is a very hands-on, projects-based course, and all you need to get started is going to be prerequisite knowledge of HTML and JavaScript, and a code editor such as Atom or Brackets or Visual Studio, or even an online code editor like JSBin or CodePen. Let's jump in and cover the first part of the course, Tensorflow Js Fundamentals. In this part of the course, we're doing a course overview. That's where you are now. You're going to learn what is Tensorflow JS, and you'll learn how to load TensorFlow into your website. Then we will build our first tensors. You'll learn what is a tensor. We'll also do a quick review of linear algebra for machine learning. Not too much math, don't worry. We'll learn how to build tensors, how to use tensor utility methods, and how to perform math with tensors. The tensor is the basic building block of TensorFlow, so we are going to have a whole section doing an overview of how to work with tensors. Then, part 2, we are going to learn how to visualize data. This section is going to teach you how to build different graphs like a scatter plot, a bar chart, and a histogram. Visualizing data is a key step in the machine learning workflow, because if you can't visualize your data, you can't see the trends, the potential patterns, you can't see the distribution of values. So visualizing data is very important, and you'll learn all about how to visualize data. Then in part 3, you're going to learn how to build your first model. Our first project is going to be training a simple model. You'll go through the whole machine learning lifecycle, starting with building sample data, moving on to building a model, and then making a prediction using that machine learning model. Following that, we're going to have a project where we generate and visualize data to really make sure and solidify your knowledge about data visualization. we're going to generate data from scratch and then visualize it with the help of helper libraries. We're going to use lots of helper libraries like Charts.js and Plotly, as well as P5 throughout this course. Then in part 4, we're going to cover a very common starting point for machine learning beginners, and that is known as the linear regression machine learning model. We'll have 2 projects on linear regression. First, we're going to build our first linear regression model. You're going to learn what is linear regression in the first place. We'll do a quick overview of the theory behind the model. Then we'll jump into coding a hands-on project where we will prepare training data. Then we will build the linear regression model. And finally, we'll use that model to make a prediction. Then our second project is going to be visualizing linear regression with dynamic data that comes from the user. So we'll actually have a dynamic data set that will take in user input to create data. For this project, we'll set up our canvas, we'll learn how to draw data samples, we'll create loss and prediction functions, we'll learn how to collect user input for our data set, and finally, we'll learn how to visualize linear regression on our data set. Then moving on to part 5, we are going to learn another common machine learning model, which is one step above linear regression in terms of complexity. And this machine learning model that we will build is known as polynomial regression. Our first project is going to be visualizing polynomial regression with a dynamic data set that comes from the user input. For that project, we're going to set up our canvas, set up our model, and then visualize regression. And then for our second project, we're going to build a polynomial regression model from scratch. We are going to generate samples, we're going to generate a prediction equation, we're going to train the model, and then visualize not just the predictions that the model can make, but also the accuracy and error of the model. And then our final part is an image classification project. We're going to build another machine learning model known as the k-nearest neighbors model type. And we're going to use it to perform image classification on the web. All of our projects are going to be web-based, where we learn how to use machine learning in a website or a web app. For this project, we're going to load pre-built models into our website. We're going to train the model on our data set of images, and then we're going to use this model to make a prediction based on training. In our case, we're going to train it how to distinguish birds from zebras. So our model will learn what is a bird and what is a zebra, and we will do that with the machine learning model type known as k-nearest neighbors. This is another common fundamental machine learning model. And those are our projects. That is what we are going to learn in this course. Again, it's very hands-on. We're going to have a whole range of projects, and you can find the setup files, the image files, and the completed files for each section at the last lecture of that section. I'm excited to go ahead and get started. Coming up, we're going to talk about what is Tensorflow Js in the next lecture. So join me over there. Hello everyone, and welcome back to our Tensorflow Js course. In this lecture, we're going to learn what is Tensorflow Js. Let's jump right in. Tensorflow Js is a machine learning library for JavaScript. It contains many pre-built functionalities that allow us to bring machine learning into our JavaScript projects. Tensorflow Js is available in the web browser and also on Node.js. It's easy to set up, it's free, and you can either set it up via a CDN or via Node. We'll show you exactly how to load it into your web projects coming up. Why do we use TensorFlow Js? Well, TensorFlow Js allows us to access device features like the camera, the microphone in our machine learning projects. That means we can make machine learning projects taking in data from a webcam, from a microphone. As well, TensorFlow Js allows us to add machine learning into JavaScript apps. You can put machine learning into Vue, into React, or into any website you make, or web app for that matter. And with TensorFlow Js, you can also import TensorFlow Python models. So you're not limited to only JavaScript models. You could make models in Python, or you can find models that have been made in Python, and you can use them with TensorFlow Js. So it's highly flexible. Let's compare TensorFlow versus TensorFlow Js. Regular TensorFlow came first. It was released in 2015, and typically it's used with Python. As well, regular TensorFlow was partially implemented in native C++ code. Now, TensorFlow Python cannot run in the browser. That's why we use TensorFlow Js if we want to bring machine learning to browser projects, because TensorFlow Js provides the same functionality as TensorFlow Python but with JavaScript. Let's talk about the similarities between TensorFlow and TensorFlow Js. Both are open source, meaning they're free for you to use, and both are libraries full of machine learning functionality. That means they'll save you a lot of time from having to write machine learning algorithms yourself from scratch, because the libraries have a lot of pre-built objects, classes, and functions that will help you perform machine learning faster. Both are made by Google, and they have similar APIs. Not identical APIs, but similar. Let's talk about the performance of TensorFlow Js next. JavaScript is not as fast as native code, but TensorFlow Js is still fast. Deep learning is possible with TensorFlow Js. That means you can build neural networks with TensorFlow Js. And in fact, there are many pre-built models, including many pre-built neural networks, ready for you to use in your web projects. Also with performance, there's optimized backends in TensorFlow Js. TensorFlow Js uses GPU in the browser for accelerated performance, for faster processing, because with machine learning models, typically you're working with a lot of data and you're working with a lot of processing, so you need the GPU to help you accelerate your processing. Otherwise, you'll be sitting around for a long time waiting for your machine learning models to complete. As well, TensorFlow Js uses native bindings with Node.js. This means that if you load in TensorFlow via Node, you will have slightly better performance. And that is TensorFlow Js. I'm very excited to take you through our course of building projects with TensorFlow Js. Now that you know what it is, we can get started with bringing it into our web projects. So join me in the next lecture. We will load TensorFlow into an HTML file. Hello everyone, and welcome back to our TensorFlow JS course. In this lecture, I'm going to show you how you can load TensorFlow JS into your web project. There are several ways to load TensorFlow JS. The simplest way is to use a CDN, just like I have right here. You can see I have here an HTML file, and I have included in the head a script tag where the source is to this URL, and this URL is the location to TensorFlow JS via a CDN. That means I can load in TensorFlow JS as long as I have internet. Another way to load TensorFlow JS is via Node. So if you are familiar with Node.js, then you can load TensorFlow JS via Node. Otherwise, just use this script tag like so. You can find this file at the end of this section in the source files lecture. Okay, so we have loaded TensorFlow JS via this link. how can we verify that we indeed do have our TensorFlow object? Well, inside of our script tag is where we write any functionality that we want to occur. For example, I can call console.log of tf, and this is going to log to my developer console the tf object. You may be wondering, what is tf? I haven't defined tf anywhere. Well, tf is the keyword for the TensorFlow object. The only reason I can use tf without declaring some variable called tf is because I have loaded in TensorFlow Js via the CDN. You can see here we have tf.min.js. Regardless of the CDN link, the name of TensorFlow is tf in our project because in the TensorFlow Js library, inside of the class files, there is an object called tf. This represents the whole TensorFlow library, and the tf library has many different functions. It has sub-libraries like train, it has functions that you can use for machine learning. For now, let's just start by logging out tf. I'm going to save this HTML file, and I'm going to open it up in my browser. I will hide my code editor, and I'm going to open up my browser. Here on the website itself, I don't see any content, but if I go to More Tools and Developer Tools, this is going to pop open for me the console. This is the developer console where I can see anything that I've logged. I have one line that's been logged, and it says an object. If I click on the arrow, I can expand the object, and this is the TensorFlow object. And here we can see all types of classes inside of the object. These are all classes available for us to use, and functions as well. Here we have different activation functions for machine learning, different model layers for machine learning, and much more. TensorFlow is a huge library full of helper functions and models for you to perform many machine learning tasks. Make sure that if you're following along with this lecture that you have this object being logged in the console, because if you have this object being logged, that means that you are successfully able to load in TensorFlow Js into your project, because we called console.log tf, and tf is the whole TensorFlow library object. Awesome. Once you've verified that you indeed can log out the TensorFlow object, that means you're good to go and you can use TensorFlow anywhere you want in this project. Now that we have learned how to access the TensorFlow Js library, let's start building our first machine learning model with TensorFlow. We'll start on that in the next section. I'm excited to start our new project, so join me over there. Hello everyone, and welcome back to our TensorFlow Js course. In this lecture, we're going to do a quick review of linear algebra for machine learning. We will cover some fundamental data types and linear algebra structures that you need to know to be able to jump into machine learning projects. Starting with our first type is known as the scalar. A scalar is also called a zeroth order tensor. Now what does that mean? Well, to simplify it even further, a scalar is a single number. Some examples of scalars are integers, floats, or even bytes. Some concrete examples are numbers like 0, 1, 7.5, 7.45. You get the idea. Whenever we refer to a scalar in machine learning, we're talking about a number. Next up, we need to know what is a vector. A vector is one step up from a scalar. A vector is a first-order tensor. That means it's an ordered array of single numbers, kind of like a list. One example is an array containing the numbers 1, 2, 3. That is known as a vector. Next up, let's talk about a matrix. When we refer to a matrix, we're talking about a second-order tensor, so one step up from a vector. A matrix is a rectangular array of numbers, kind of like a table of data. For example, if we have a two-dimensional array of 1, 2, 3, and 4, 5, 6, that is a matrix because we have a multi-dimensional array. So whenever you have a two-dimensional array, you have a matrix because you have a table. You have 2 rows in this case and 3 columns. And finally, we need to know what is a tensor. A tensor is a multi-dimensional array of numbers. You can have a one-dimensional tensor, which would be a vector, or you can have two-dimensional, three-dimensional, etc. You can have multi-dimensional arrays of numbers. For example, if you had a two-dimensional tensor, that would be a matrix. The difference is that if you convert your vectors or your matrices into tensors, then they can be backed by accelerator memory, such as a GPU. The reason we want to convert our types from vectors and matrices into tensors is because when we're working with machine learning, often we have a lot of data or we have a lot of loops that we have to process for our models. Therefore, we need to accelerate our models at times. We need to accelerate our processing. That's why we are going to often see data will be put into not just regular vectors and matrices, but they'll be put into tensors of different dimensions. And that is because with TensorFlow, we can work a lot faster with data than we could with regular arrays and regular lists. All right, and that is what we need to know in terms of linear algebra before we can jump into our machine learning projects. Now, of course, if you want to become a machine learning specialist, there's a lot more linear algebra that will be very useful for you to know. There's a lot more you could learn about matrices, matrix operations, and tensors. But for our purposes, we have covered the fundamentals of linear algebra that you need to know. Now that you know these 4 terms of scalar, vector, matrix, and tensor, whenever we talk about these in our upcoming projects, you'll be able to understand what we're talking about, what shape of data we are referring to. All right, that is linear algebra for machine learning. Join me in the next lecture. We're going to jump into coding our first tensors. Hello everyone and welcome back to our TensorFlow JS course. In this lecture, we are going to get started with building and working with tensors. I have here for us a very bare bones HTML file. We have some metadata information as well as a script that is loading TensorFlow JS via a CDN. Okay, now inside of our body we have an empty script tag. Here is where we will write the functionality for building our first tensors. You could also make a JavaScript file as another option instead of putting it directly here into the body. Okay, let's get started. I am going to make an asynchronous function that I will call run, and inside of this function is where I will write my functionality. Let's get started with making our first tensor. I will make a constant called my tensor, and I'm going to use TensorFlow JS with the keyword tf dot tensor. Tensor is a function that will make a new tensor, and you can put in the tensor that you want. For example, if I want to make an array containing the values 0, 1, 2. Well, just like that, I have created a tensor. Every tensor has several properties. One property is the rank. Let's start by putting in a line that is going to show us the rank of the tensor. So I will call console.log, and I am going to print out my tensor.rank. Rank is a property, not a function, so that is why we don't have any parentheses after it. So this is going to log to my console the rank of the tensor. Now, to run this function, I'm going to add in a check. I'll check if document.readyState is not equal to loading. That means my document has been loaded and I can call run. Otherwise, I am going to add an event listener, and this event listener is going to listen for when the DOM content has been loaded, then I will run. I'm just doing this because I don't want my run function to be called too early before the document has been loaded. So that will help cover our bases. Okay, now let's save this file and let's open it up in our browser of choice. And then we can open up our developer console and see the rank of the tensor. Okay, so I will refresh this page, and the page won't have anything, but if I open up my developer tools, well, look at this. In my developer console, I now see 1 being printed out. And if I go back to my code, I'm going to see here, 1 is the rank of the tensor. So what is rank? Well, the rank of a tensor refers to its dimensions. So I got printed out 1 because my tensor is of 1 dimension. It's kind of like a one-dimensional array. If I had a matrix or a table, then I would have a 2-dimensional tensor. Let me add here the my tensor.rank as a string in front of the rank so that we actually know what's being logged out. Okay, and back in my browser, we can see here my tensor.rank is 1. Okay, great. We can clear the console, and what if we wanted to show an example of a tensor that had a rank of 2? Well, for that, what we would do is we would make a multi-dimensional array. Okay, so for example, I would have one array inside of the other. So here I have one array, and then I would make another one with 3, 4, 5. Okay, well, let's take a look now. Let's save this and go back to Chrome and rerun it. And look, now in our console, my tensor.rank is 2. The rank is 2 because the tensor is now 2-dimensional, not 1-dimensional. It's 2-dimensional because it has a nested array. It's a multi-dimensional array. And let's say I nested the array even more. Let's say I put in another array in here, or maybe at the end. Well, then I would then have an array and a tensor rank of 3. So for example, here I would put in, because I now have 3 square brackets here, that tells me I have the opportunity to put in a nesting of 3. So now if I refresh, my tensor.rank is 3. Alright, so that is rank. Rank also refers to dimensionality. Let's just put it back to a one-dimensional array, so a tensor of rank 1. Next up, another property each tensor has is the shape. The shape refers to the size of each dimension. Okay, so let me go ahead and I'm going to add console.log, and I'm going to log my tensor.shape. Again, it's a property. Now if I go back to my console and I refresh, first I have the rank, which is now 1, and then I have 3 inside of square brackets. So this is the shape of the tensor. It's telling me that I have 3 items inside of an array inside of a one-dimensional array, to be exact. Now, let's say I add in a second dimension. Let's say I put in a two-dimensional array. Well, now my rank is going to be 2, and my shape will also be changed. I'm going to go back to my browser, and look, now my rank is 2, and my shape, first I have 2, signifying that there are 2 arrays in the tensor. The rank is 2, and then I have the actual contents 2 and 3. If I go back to my code, I can see that reflected as such. Okay, let me put this back to a one-dimensional array. Now that we have the rank and the shape, we can also get the D type, which refers to the data type of the tensor. So I can call console.log, and I can log out my tensor.d type. And it's just lowercase all the way, by the way. And now if I go into my browser and refresh, my type is a float 32. So by default, when you put numbers into tensors, their type will be a float 32, meaning they can contain decimal numbers, and there will be 32 bytes per number. Alright, so that is how you can access 3 different properties of tensors. Now, what if we wanted to log out the tensor itself? Well, to log out a tensor, we could do console.log of my tensor, but there actually is a custom function from Tensorflow Js. I will show you how to log out console.log first. So let's say we did console.log tensor and then refreshed. If we did console.log, we get all of this information about the tensor and all of its properties, like its data type, its ID, its rank type, its shape, its size, its strides. That rhymed. Okay, but if we wanted to log out not all of the properties, but just the values of the tensor, then what we can do is call myTensor.print. So print is a custom function of the tensor object. So now if I go back to my browser and I refresh, this last line, that is printing out the tensor. We have tensor 0, 1, 2. So we're seeing the contents of the tensor instead of looking at the tensor object. Okay. You see, when we call console.log, we don't see the contents here. What we see instead is information about the object. So if we want to actually see the contents, we call tensor.print. Okay, and I'm going to go back to my HTML file, and here is my code for that. Now, we don't just have to create tensors that are of type float or numbers. We could also make tensors with other data types, like, for example, strings. I can make a constant I'll call string tensor, and I can use tf.tensor. Then I could put in an array of strings, such as mammoth interactive toStrings. Then if I call string tensor.print, I will see the 2 values in that tensor. Here we go. We see tensor mammoth interactive. And similarly to how we made our tensor of numbers, we can also get properties about this tensor of strings. For example, we can call console.log and we can get the string tensor.shape. That's a property of the string tensor. And if I refresh, there it is, 2. 2 is the shape, because there are 2 in terms of the dimensions, and it is inside of a one-dimensional array. Okay, so now back in TensorFlow JS, we learned how to make a tensor that is of type number and of type string. If we want to make two-dimensional tensors, the best way to do that is to use the function tensor2d. So we'll make a constant called two-dimensional, and we'll use tf.tensor2d. That's the best way to make two-dimensional tensors. Now we still use the same format, for example 0, 1, 2, and 3, 4, 5. So we still have the same format here, where we're opening up with square brackets a multi-dimensional array, and then we're just converting that to a tensor array format. But we're using tensor2d instead of tensor. Then I can still use the same functions like two-dimensional.print. I can print out the values of the two-dimensional tensor. But we do want to use tensor2d because that is specifically for two-dimensional tensors. Okay, and there is our two-dimensional tensor. We see its values 0, 1, 2, 3, 4, 5. Great, so that is how you can create tensors. Congratulations everyone, you now know how to create tensors of different types and also how to access information or values about the tensor. Coming up in the next lecture, we're going to learn how to use utility methods that come from the Tensorflow Js library. These utility methods, they will help you work with tensors even further and be able to manipulate the tensors. Join me in the next lecture where we will learn how to use tensor utility methods. Hello everyone and welcome back to our Tensorflow Js course. In the previous lecture we learned how to build our first tensors. In this lecture we're going to learn several utility methods from the Tensorflow Js library, and these utility methods will allow us to manipulate and change tensors even more. Of course, there are many utility methods that you can find in the documentation, but let's get started with learning how to use some of them. We'll start with the Reshape Utility method. Okay, so currently we have two tensors that we made in the previous lecture. We made my tensor, we made two-dimensional. Let's make another tensor. We'll use tf.tensor to create a new tensor, and let's fill it with some values like 0, 1, 2, 3, 4. Okay, so here is a tensor that we've made. We can use the utility method reshape to reshape the tensor. Let's say we want to reshape it into 1, 2. Then after that we can also append print. So we can append print right to the reshape function. Just make sure you don't have any semicolons before that. As long as the semicolon is the last line, then this whole appending of functions will be treated as one big function. Okay, let's go ahead and see what we have now. I'm going to enter my console and refresh. Okay, then we get this message that the size 5 must match the product of shape 1, 2. So it's important to note when working with tensors that if you want to reshape, the product of 1 and 2, so 1 by 2, because this is the number of rows and columns that you want to reshape to, the product must match the number of items in the tensor. So we currently have 5 items in the tensor. Let's put in another one, and then let's change this to 3, 2. So now we have 6 items in the tensor, and the product of 3 by 2 is 6, so this will match. Then in Chrome, let's restart. And okay, let's take a look now. Our original tensor contained 0, 1, 2, 3, 4, 5 as one big tensor, but then we reshaped it into 3 rows by 2 columns. And to understand this even better, we can print out the original tensor versus the reshaped tensor. Okay, so let me add console.log original tensor, and then I will print out tf.tensor of the original size. So I'll append the print function to it, and then I'll call console.log reshaped tensor, and I will print out the tensor after it's been reshaped. Okay, so then in our browser here, I'll refresh. And okay, here our original tensor contains 0, 1, 2, 3, 4, 5. It's a one-dimensional array, a one-dimensional tensor, also known as a one-dimensional tensor array. But then we reshaped it and we put it into 3 rows by 2 columns, also known as 3 subarrays with 2 items per array. And we managed to do that because our code used reshape of 3 by 2. So we reshaped the one-dimensional array into 3 rows and 2 columns. Let's say we did 3, 2, 1, then we tried again. We'll now take a look. Now our reshaped tensor, it's been placed into an even further reshaped array, so even more dimensions now. Now we have one subarray inside of the original array, and then inside of each subarray we have 2 items with 1 item per array. So you can play around with this reshaping, but the point is, with reshape you can change the dimensionality and the number of items per array. But just make sure that the product of the reshaped dimensions equals the number of items in the original tensor. We have to have product be equal, otherwise all of the items cannot be evenly dispersed in your new reshaping. Okay, other than reshape, another commonly used utility function is to make a tensor full of zeros or ones. For example, let's start with ones. We can call tf.ones, and this will make a tensor that's populated with ones. Then in the parentheses, in the argument, we pass in the dimension. For example, I could make a tensor of dimensions of 4 by 5, okay? And then I can append print to print out the result. This will create for me a tensor of dimensions 4 by 5, and it will all be filled with ones. I can show you here. Look at that. Here is my tensor. I have 4 rows and 5 columns, and all of the values are 1. This type of tensor is commonly used for mathematical operations in machine learning. Other than ones, there's also zeros. You can create a tensor of zeros as another option. Knowing how to manipulate tensors like this and create new tensors is essential to machine learning, because at the core of machine learning and the data you use for machine learning are tensors, because you'll have to convert your data into the tensor format. Alright, there are many more utility functions. For example, I can show you one more, tf.truncated normal, and I will make the size 3 by 4 and print out the results. I encourage you to look in the documentation for even more utility methods that you can play around with and use in your machine learning projects. Take a look at this. If we use truncated normal, I'm just going to zoom out a bit, we have a 3 by 4 tensor array, meaning we have 3 rows and 4 columns. And here we have populated with an assortment of values. And we alternate between negative and positive values randomly. Okay, so those have been some of the most commonly used utility methods with tensors. We'll see them used later on when we build our projects. Coming up, we're going to continue our look at tensors, and we're going to learn how to perform mathematical operations on tensors. This is one of the most crucial topics because you have to know how to resize and multiply tensors in order to be able to format your data properly. With machine learning, you'll find often that getting data properly formatted for your machine learning task can be even more time consuming and challenging than building out the machine learning model itself, because often data is so messy and it's so in the wrong format. So understanding how to multiply matrices, add matrices, transpose matrices is crucial to many machine learning model operations, as well as for getting your data ready in that data preparation phase. Finding and preparing data is essential to your machine learning project because without data you can't even perform the machine learning projects you want. So in the next lecture, we're going to learn how to perform that essential task of performing math with tensors. I hope to see you in that next lecture. Hello everyone, and welcome back to our Tensorflow Js course. In the previous lecture, we learned how to use some of the most common utility methods with tensors. And in this lecture, we're going to learn how to perform math with tensors. All right, let's get started. First off, we are going to need some sample tensors to work with. So let's make one constant that we will call our first tensor. We can call it something like, for example, blue. Just a random name really, and then we will use tf.tensor to make a new TensorFlow JS array, a new tensor. All right, let's populate it with some values like 0, 1, 2. Then let's make a constant called, for example, red, and we will use tf.tensor to make another tensor, 3, 4, 5. Okay, great. So now we have here two tensors, and we can perform mathematical operations with these tensors. For example, we could add the two tensors together. For that, I will call one of the tensors, such as blue, and I will call add. Then I will add red to blue. And I can append print to print out the result. Let's pull open our browser and refresh our page. And look, here is the result. The result is 3, 5, 7. That is the result of adding all of the values together. And I'm just going to print out blue and red so that way you can see the values of blue and then the values of red and then the values after they've been added together. Okay, so let me refresh. Here, first we have blue, 0, 1, 2. Then we have red, 3, 4, 5. And when we add them together, we add the columns. Simple enough, right? We add each item at the corresponding index. First we add together index 0, then we add together the values at index 1, then we add together the values at index 2. Addition and subtraction, those are quite straightforward with tensors, but with other operations it gets more complicated because you're working with not just numbers, but you're working with arrays. So another very common function that is performed with tensors is known as the dot product. So let's go ahead and next up we are going to perform the dot product. So instead of doing add, we will replace add with dot. Okay, so now we're doing the dot product of blue times red. And I will refresh my browser here. And look here, blue is 0, 1, 2, red is 3, 4, 5, but my result is 14. That's because my result is performing the dot product of the first tensor by the second tensor. Let's try another example. The dot product can be one that you have to wrap your head around because it does require some spatial visualization if you've never done the dot product before. So let's start with 0, 1 by 3, 4. Okay, so we will take the array 0, 1, and we will dot product it by 3, 4. I'm going to refresh my browser here, and the result that we get here is 4. So I encourage you to test out different dot product operations. If you still don't understand dot product, then yes, definitely performing different operations will help you wrap your head around the dot product. Operations like the dot product are commonly used in order to multiply two tensors by each other on one axis. So you will multiply the row of one tensor by the column of the other tensor. Okay, another common operation is known as transpose. This is flipping the axis of the input tensor. Okay, so let's try out the transpose math function next. Let's make a tensor, a simple tensor like, for example, containing 4, 5, 6, 7. Okay. Then let's apply dot transpose to the tensor, and then let's call print. And just make sure your semicolon is at the very end of all of the lines. Then I'm just going to also print out the original tensor so we have it for reference first. So first we'll print out the original tensor, then we will transpose it and see the result that we get. Okay, let's pull open our browser here. Our original tensor was 4, 5, 6, and our flipped axis version is the same, 4, 5, 6. That is the case for one-dimensional tensors because there is only one axis. But let's say we add in a second axis, okay? What I'm going to do is I'm going to split this tensor in half and make it two-dimensional instead. So I have to first off make two tensors, and then I have to also put them all into one. I can't just have two of them side by side. They have to be enclosed in one giant tensor. Okay, so now this will be slightly different because now we have an x-axis and we have a y-axis. It might help you if I add a space here because you see now we have the x-axis of rows and we have the y-axis of columns, and we are going to flip the axes. Let me show you what I mean. I'll refresh my browser. Look here. Our original tensor was 4, 5, 6, 7. But then we flip the axes and we now have 4, 6, 5, 7. So what we did is we took the row and we made it the column. Then we took the second row and we made it the second column. That is the transpose function. Let's try it with some more values. Like I'm going to add here 8, 9. Sometimes showing more examples and trying out more examples will help you understand these functions better. Okay, so now we have 3 rows and we have 2 columns. But we're going to transpose the tensor. So before we run it, try to visualize what it could look like because we're going to flip the axes. We'll now have 3 columns and 2 rows. Let's go ahead and run the example. Look at that. We start off with 3 rows and 2 columns, but then we flip them. The rows become our columns and the columns become our rows. So it's like flipping the array on its side and also shifting all the values. Transposing is commonly done, so we have to know how it works. For machine learning, if you really want to become an expert machine learning specialist, then having a knowledge of linear algebra and working with matrix transposing and multiplying, as well as math like linear algebra, will help you with more complex machine learning tasks, especially if you have to build out your own machine learning models from scratch and prepare and process your own data. Being able to understand tensors and linear algebra is important if you want to become a high-level machine learning expert. If you want to just understand the basics, then you don't need to have a high-level understanding. But just for the future, if you are considering a long-term career, then understanding the linear algebra and tensors is going to be even more important the more high level you get. Okay, but for our purposes, these three common mathematical operations that we've looked at so far, adding, dot product, and transpose, those are enough for our beginner purposes because now we know how to perform the crucial, most common mathematical operations on tensors. We know add, therefore we also know subtract. We know the dot product, we know transpose, and we're going to be putting these to use throughout various projects later on in this course. Awesome, so now we know how to perform math with tensors. Next up, we're going to start a brand new section. Okay, what we're going to do in the next section is we're going to learn how we can visualize data with Tensorflow Js and with a helper library known as TensorFlow Visualize, TF-Viz. So I'm excited to take you to our next section. So I hope to see you over there.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.